Okay, this is the outline of my class today. As you can see on this slide, I will start with a brief introduction on basic concepts of statistics and SPSS, which includes measurement scales and different types of variables. And then I will move on to SPSS interface and how to enter data in SPSS and how to import external data into SPSS and also how to clean and edit data. And we also will talk about data transformation in SPSS. And then we will focus on how to select appropriate statistical tests for particular types of data and how to get descriptive and inferential statistics. And finally, how to report a statistical output in a concise and appropriate manner. So I believe that for many students, using statistics in their research is a major source of stress and frustration. So the aim of this session is actually to provide a simple, step-by-step guide to the process of data analysis using SPSS. So I'm not focusing on mathematical techniques behind SPSS, so don't worry on that, okay? So hopefully this session will give you the confidence to tackle statistical analysis calmly or at least without too much stress. Okay, before I start, let me tell you that I have divided my lecture into 3 parts. First part focuses on understanding basic concepts of research and statistics. The second part focuses on an introduction to SPSS data entering and data cleaning, and also how to check validity and reliability of the survey items. And then last part focuses on data analysis, both descriptive and inferential statistics, and how to report the output. Okay, so let's get started. I believe that when we understand the purpose of a lesson, we will learn more, right? So before we start, I want to show you kinds of questions that cross our minds. So before we start our data analysis, some questions that you need to ask before delving into analysis. Who is the audience that will use the results from the analysis? What is the question you are trying to answer? Do you know exactly what you are trying to measure? So it is extremely important to at least have an idea of what question you are trying to answer and how you are going to address, those questions, those specific questions. So you must prepare your data file first and enter your data carefully. And you should have a clear idea of your research questions and how you might go about addressing them. And also you need to know what statistical techniques are available and how you are going to perform those, those tests. Maybe, for example, t-test, ANOVA, correlation, regression, okay, whatever it is. And finally, you need to relate the outputs back to your original research question and know how to present these in your report. So in order to answer to some of these questions, of course not all, but some of these questions, let's start our session. So here I just want to introduce one of the best SPSS textbooks. I believe that the best book I ever used for teaching and research purposes is this book. One of the advantages with this book, SPSS Survival Manual, is the thought-through structure of this book. It is very easy to apply, very easy to understand for everyone, for lecturers, for students, for master students, for PhD students, and also those researchers who have, more experience on using statistical techniques. And there is a reason they have a life preserver on the front cover. So as you can see on this slide, okay? I will upload the PDF version of this book on eLearn later, okay? Then you can download from eLearn the PDF version of this book. All right. This slide shows some basic terminologies in SPSS, okay? Language of research, some basic terminologies of statistics. Any scientific discipline needs a specific language for describing and summarizing observations in that specific area. So let's learn some of these terms which are the language of statistics. So I would like to start with, giving an overview of variables, of, measurement skills, of different types of, questionnaire, and so on. So let's get started. Let's start with statistics. So what is statistics? Statistics is the science of collecting, organizing, presenting, analyzing, and interpreting numerical data to assist in making more effective decisions. So the interpretation of data is designed to help people make sense of numerical data that has been collected, analyzed, and presented. Okay, so this is the definition of statistics. All right, so next is methodology and instrument. Research methodology is the specific procedures or techniques used to identify, select, process, and analyze information about a specific topic. More specifically, it's about how a researcher systematically designs a study to ensure valid and reliable results that addresses the research aims and objectives. And research instruments are measurement tools, just like, a questionnaire, survey, or interview or observation checklist designed to obtain data on a topic of interest from research subjects. All right, let's move on to construct. Okay, which is very important in statistics. Constructs are abstractions that cannot be observed directly. Okay, so cannot be observed directly, but are useful in interpreting empirical data and in theory building. Okay, what does it mean? Actually, constructs are concepts at very high levels of abstraction that have general meanings. Okay, let me give an example. For example, people can observe that individuals differ in what they can learn and how quickly they can learn it. Okay, so to account for this observation, scientists created a construct called intelligence. They hypothesized that intelligence influences learning and that individuals differ in the extent to which they possess that trait. So intelligence cannot be directly measured, right? So they use some items in order to measure that specific construct. Those items you can find in your questionnaire, right? Let's say you are going to measure safety. Okay, here. Okay, this slide shows, two examples of constructs. Let's say you are going to measure safety in, the tourism context. Okay, you have three items in order to measure that specific construct, which are travel safety, personal security on board, and personal security at the station. So in that specific, context, we are going to use three items in order to measure one big construct, which what we call as safety. Okay, another example is comfort. Crowding on board, air conditioning on board, and comfort on board. So, okay, these all are based on literature review. We cannot create the construct by ourselves. No, never. Okay, so we use the literature review in order to develop the survey instruments and also in order to define our constructs in our study. Okay, is variable, which is very important. Okay, so what is a variable? A variable is a construct or a characteristic that can take on different values or scores, right? So variable is defined as anything that has a quantity or quality that varies. Just like, social class, like gender, like vocabulary level, intelligence, safety, okay, whatever. These are some examples of variable. So a variable is defined as anything that has a quantity or quality that varies. Okay, so this is the definition of variable. All right, types of variables, categorical and continuous variables. Okay, actually there are several ways to classify variables. Variables can be categorical or they can be continuous. When researchers classify subjects by sorting them into mutually inclusive groups, the attribute on which they base the classification is termed a categorical variable. Okay, a categorical variable. Just like home language, county of residence, gender, ethnicity, these are some examples of categorical variables, okay? Like gender, male, female, okay? They are two independent, category in that specific variable. So we call them as categorical variables. On the other hand, when an attribute has an infinite number of values within a range, it is a continuous variable. Okay, as a child grows from 40 to 41 inches, he or she passes through an infinite number of heights, right? So height, weight, income, age, and achievement test scores, they are some examples of continuous variables. Okay, so this is the differences between categorical and continuous variables. All right, next. Next, dependent and independent variable, which are very important. Okay, so as I have mentioned just now, a variable is defined as anything that has a quantity or quality that varies, right? In all quantitative studies, we have IV and DV. IV stands for independent variable, DV stands for dependent variable. So an independent variable is exactly what it sounds like. It's independent. Okay, it's independent. It is a variable that stands alone and is not changed by the other variables you are trying to measure. Okay, while dependent variable responds to the independent variable, it is called dependent. Okay, so because it depends on the independent variable. Okay. So DV or dependent variable is the variable of interest, right? Okay, so because we want to test the impact of our IV on our DV. Okay. So at the end, actually, we want to examine how much of the variance in the dependent variable is explained by our independent variable. Okay. So this is the differences between dependent and independent variables. Okay, next is mediator and moderator. All right. So in addition to IV and DV, which are independent and dependent variables, there are some other variables that explains the relationships between IV and DV, which are moderator and mediator. These are very important, especially in PhD, PhD studies. you will have, some moderator or mediator depending on the scope of your study. Okay. So the direct effect is not mediated. Okay, just like C prime. As you can see on this slide, we have three variables here, x, y, and m. The direct effect is from x goes to, y. Okay, so the beta value is C prime. This C prime is not mediated, it's just direct effect. Whereas the indirect effect is transmitted through one or more mediators here, okay, or variables here. In this example, M is mediator. Okay, M is mediator. So the indirect effect from X to Y goes through M. Okay, so this is the mediator. A mediating variable explains the relation between our IV and DV. It explains how or why there is a relation between two variables. Okay, and the total effect here in this example, we have one IV, one DV, and one mediator, right? So the total effect of X on Y, is direct effect plus indirect effect. In this case, our direct effect is C prime, our indirect effect is A times B. A times B. Alright, so this is the total effect of the mediation. Alright, okay, next. Next is moderator. Another important variable is moderator, and also it's important not to confuse a mediator with a moderator, okay? So a moderator is a variable that affects the direction or a strength of the relationship between a predictor or IV and an outcome or DV. As you can see on this slide, we have three variables here. One is IV to DV, right? There is a direct relationship between IV and DV, right? So the mediator will affect the relationship, the direction or a strength of the relationship between IV and DV. Okay? So this is the differences between mediator and moderator. Okay, next. Alright, levels of measurement, which is very important whenever you are using SPSS. Okay, so let's talk about the levels of measurement. These levels of measurement tell you how precisely variables are recorded. How precisely the variables are recorded. There are four measurement levels. The first one is nominal, next is ordinal, interval, and ratio, which are very important to understand these four because we will always use, these variables in our SPSS. Okay, so let's start with nominal. Nominal or categorical data is data that comprises of categories that cannot be ranked order. Each category is just different. It comes from name, you see, nominal. It comes from name. It's just name, gender, just like gender. Male, female. We cannot rank them in order, right? We cannot say which one is better. No, never, right? Just like, color, blue color, green color, and so on. Okay, so we just use some labels in order to differentiate the categories in our variable, right? So when measuring using a nominal scale, one simply names or categorizes the respondents female, male, blue, green, purple color, pink color, whatever it is. Okay, so the favorite color, ethnicity. Okay, so these are some examples of variables measured on a nominal scale. The essential point, about nominal scales is that they do not imply any ordering among their responses. For example, When classifying people according to their favorite color, there is no sense in which green is placed ahead of blue. No, cannot, right? So responses are merely categorized, and this is the lowest level of measurement. Okay. Next is ordinal. Ordinal scale. It comes from order, so meaning that we can rank them in order, right? So ordinal data is data that comprises of categories that can be ranked ordered. With ordinal scales, the order of the values is what's important, but the differences between each one is not really known, right? Okay, for example, the level of agreement. We have a Likert scale, 1 to 5. 1 is extremely disagree, 5 is extremely agree, right? Okay, let's say I choose 4. Okay, you choose 3. Can we find the distance between these two? No, it's not possible, right? So we can rank them in order, but distance is not meaningful here. The distance between responses is not meaningful here, just like, agreement, just like satisfaction. Okay, like this. So all Likert scales are this kind of scale. They are ordinal scale. Okay, next level, which is at a higher level, is interval scale. Interval scales are numeric scales in which we know both the order and also the exact differences between the values. For example, temperature. Okay, so let's say we have, the temperature is 10 degrees or maybe 0 degrees. So we know that the differences between these two responses is 10 degrees, right? But in these interval scales, we do not have a true zero. Okay, there is no such things as no temperature. Okay, so meaning that zero temperature is not no temperature. Okay, so zero doesn't mean the absence of value, but is actually another number used on this scale, like 0 degree, right? And also negative numbers have meaning, right? They are also meaningful. So the distance here is meaningful, but we don't have true zero. Okay, the last one, which is the highest level of our measurement, is ratio. Ratio scales tell us the exact value between units, and they also have an absolute zero, which allows for a wide range of both descriptive and inferential statistics to be applied in SPSS. So good examples of ratio variables include income level, height, weight, duration. Okay, for example, when we say my income level is 0, okay, means that I have no salary. It's like that. So 0 income means no income at all, right? Okay, so okay, don't worry on that. Interval scale and ratio scale, they are very close actually in the definition. So sometimes researchers, they are not able to differentiate these two measurement scales in SPSS. Both of them, I mean interval and ratio scale, they named as a scale. A scale in SPSS. We will consider these two in a in a same category, okay? In a same category that we will talk about that later on, okay? So this is the differences between these four measurement scales, which are very, very important in SPSS. All right. So why is level of measurement important? Before we can conduct a statistical analysis, we need to measure our variables, right? So exactly how the measurement is carried out depends on the type of variables involved in the analysis. Different types of variables are measured differently, right? So why these measurement skills are important? Because first, knowing the level of measurement helps you decide how to interpret the data from that specific variable. When you know that a measure is nominal, just like gender, then you know that the numerical values are, just labels. So you cannot interpret them, like a scale, other scales, right? It's like that. So the second is knowing the level of measurement helps you decide what a statistical analysis is appropriate and the values that you assign. It is very important. We need to know about our measurement scale first, and after that, we can choose our statistical test. Okay, our statistical test. So if a measure is nominal, then you know that you would never average. You cannot run mean, a standard deviation, never. Okay, mean or a standard deviation for your data whenever your data is nominal in a scale. Or maybe to run, t-test or maybe correlation. No, cannot, right? So this is very important because if you have, a nominal data, so it doesn't make sense whenever you are going to, to run correlation using, Pearson correlation. Okay, so this is the importance of knowing measurement scale. Okay, now, let's move on to coding rules. These are also very important whenever you are developing your survey items. So as you know, the questionnaire is the main instrument for collecting data in survey research. In other words, it is the heart of the survey, right? So basically, it is a set of standardized questions, often called as items, which follow a fixed scheme in order to collect individual data about one or more specific topics, right? So there are hundreds of methodology textbooks that have offered, various versions of conventional wisdom about optimal question design. The most valuable advice in this common wisdom can be summarized into these four rules. Okay, into these four rules. Okay, so let's go through one by one as they are very important when you are developing your survey items. All right, so the first one is appropriateness. Categories should include an appropriate set of response options, right? Okay, for example, your population is students at institution of higher learning. So whenever you are going to develop your categories, okay, you cannot start from 5 years or maybe 50 years, right? But as you can see here, these are logical, right? In order to measure, the age of students at institution of higher learning. So they should be appropriate. The responses should be appropriate. All right. So next is collectively exhaustive. Okay, meaning that you need to include all possible responses or all possible answers. So let's say you are going to measure the ethnicity of your respondents. So you are going to ask them, what is your race? You just include Malay, Chinese, Indians. So what about other races, right? What about other races from other countries? So if you include others here, so meaning that you are going to include all possible answers. So this is the meaning of collectively exhaustive, okay? Next is mutually exclusive. Okay, so what does it mean? It means that categories cannot both occur at the same time. As you can see in this example, we have few categories. The first one is under 21, the second is 21 to 25, next is 25 to 30 to 35. Okay, what's wrong with these categories, with these responses? Okay, let's say in this example, if a person is 25 years old, doesn't know which category to choose, B or C. Therefore, mutually inclusive and exhaustive, meaning that not be overlap between answers, and you need to include all possible answers. This is the best way in order to develop your survey items. Okay, all right. So this is not true, right? All right. So next is, okay, I want to share with you some, common wording problems. Okay, so as you can see here, the first one, in the first category, I include, 18 to 20, 21 to 30, 31 to 50, and 51 and over. You see, it's wrong because the categories are, the distance between categories is is so this is not balanced actually, right? Because 18 to 20 is only 2 years old. 2 years, the difference is 2 years. 21 to 30 is almost 10 years, right? Okay, so this is wrong. Next is 21 and under, 22 to 35, 36 to 49. So we are going to use, similar or balanced categories over here. Okay, so please bear in mind that use simple familiar words whenever you're going to develop your questionnaire. And also, another important thing here is that you are not allowed to use double negative wording questions. This will cause respondents confusion, right? This will confuse your respondents. A negatively worded question is considered as an item where disagreement would be a good answer because at the most of the times we use positive questions, and also the higher level of agreement is desirable, right? Okay, so sometimes people use negative questions as a means of reducing or preventing response bias. Okay, so that's all for basic concepts of statistics.